Imagine we want to find out the precise coordinate of a bacteria with this picture. Here, our scale is too zoomed out and you actually don't know where it is, but I'll give you a hint. I'll tell you that the bacteria is somewhere in this red circle. So great, that did help figure out where in generally it was. However, it's not much help. Our still idea of it is pretty broad and we don't know if it's going to be here, 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 or here. So what if I give you another hint? This time let's zoom up on the desk and I tell you the bacteria is somewhere here. So again, that helped a lot, but the bacteria is too small for us to precisely figure out where it is. So let's keep repeating this. Let's zoom in over and over. I give you more hints until we get more and more precise, until we eventually find it. We are able to precisely pinpoint where that bacteria is. So that's cool. Now, what if I replace this with an atom, a proton, a fundamental particle, even just a singular point, an infinitesimally small point in space? Now I tell you to find it. If that was the case, if it was just a point, we would end up repeating this process of zooming in infinitely many times. So let's now pull up the Cartesian coordinate and let's graph the function x plus 2 times x squared plus 4x plus 2 and all that divided by x plus 2 times x minus 4. We can see the general shape of the graph here, and as we approach the value of x equals negative 2, the graph seems to approach y is equal to 1/3. The closer and closer we get to negative 2, the closer and closer it approaches 1/3. However, if we look at exactly at x equals negative 2, it is labeled as undefined. This is because if you plug it into our equation, we see that we would end up with 0 over 0, which we don't know what to do at that point. Is it infinity because the denominator is 0, or is it 0 because the numerator is 0? So this is why it's labeled undefined. However, for most useful cases in the real world, if we have something like this, it is more important that we know the general shape of the graph rather than that exact point. It would be better if we knew the information about where it was approaching, where x equals negative 2 was approaching, rather than what x equals negative 2 is. So where do limits come into play? Limits is the idea that we are going to go infinitely close to that point without ever actually equaling that. We won't ever actually plug in x equals negative 2, but we'll try to see what it approaches when we plug in points that are around negative 2, and we get infinitely and infinitely close to them. So as an example for here, let's say we plugged in the points negative 1 and negative 3. Here, this gives us a general idea of the graph, and we have an idea of where x equals negative 2 would be, where the trend sort of approaches. However, it's still a pretty broad approximation. Then we become more precise by going through points like negative 1.5, negative 2.5, negative 1.9, negative 2.1, negative 1.99, negative 2.01. And we would repeat this infinitely many times until we get infinitely close, but never actually equaling x equals negative 2, because at that point, it becomes undefined and we don't know what it is. And so that is the idea of limits. We are trying to get infinitely close to that point without ever actually equaling it.